It's weird how they say this is a very small industry, but I realized I wouldn't be up here talking to you about what I'm talking about if I hadn't hooked up with Dirk and gotten back into programming, and if Jason hadn't built the product that preceded the one that I'm going to tell you about, and if people like Luther weren't filing bugs against my product like he did earlier today that I had a conversation with him about. So if you don't think this is a small industry, just step in a room in San Antonio and see what comes up. But what I wanted to talk a little bit about is how we reinvented Rackspace and some of the things we did in the latest version of our cloud. So I actually run a group called Ozone at Rackspace, and we have built the OpenStack version of Rackspace Cloud Servers, Cloud Networks, and some of the associated components. So when we decided to kind of go build the next generation of the cloud, we realized we wanted to do it open source. We really wanted to experiment by running the cloud on the cloud, our version of Inception, and using continuous delivery as a model to deliver that. So I wanted to talk a little bit about what this looked like, at least as much as I can in 5 minutes. So OpenStack, if you don't know what it is an open source project that's focused on building a cloud operating system that's completely open source. It's Python based. It's based on code that was originally contributed partially by NASA, partially by Rackspace, and has hundreds of contributors around the world that have been working for 2 solid years to get the product done. We've just rolled out our public version of the cloud that runs on this, and in particular focusing on the parts that use the compute and networking components along with some of the shared services pieces. I'd tell you a little bit more about what it is, but our deployment looks something like this, and I'm not allowed to talk about code, so I'm not going to try to go into this in too much detail. But at the high level, there's a whole series of components such as that run our API. There's databases, there's schedulers, there's things called cells, which is how we scale out. So while we look like one big cloud to the rest of the company, that's divided into some units called cells inside that we deploy in all these places. So we talk about sort of an API cell, then we have cells that have compute nodes in them that actually run servers, and then some services that are unique in every region. So you can run servers in Chicago, you can run them in Dallas, you can run them in London, and eventually more places. So this is kind of what a deployment for us looks like. It literally is hundreds of machines, in some cases thousands. In the Rackspace Cloud, just to give you some idea of scale, we currently have almost 180,000 servers that we run over about 18,000 host machines. And that's a mixture of what we call the first gen and the next gen environment. And we're doing on the neighborhood of about 700 to 800 queries per second against our APIs. So that's the kind of traction we're working with. So we actually deploy this stuff, not by building physical infrastructure, but we take all those services that I talk about, we put them on VMs. And then we use that to then run an instance of the cloud. And on top of that, we then actually come in and deploy more of those inside of that cloud. And then each one of those basically becomes our dev environment, our staging environment, and our production environment. So the Rackspace Cloud that you might be using as a public-facing customer is actually being run by servers that are running on a private Rackspace Cloud that we run inside of our own environment. So what that allows us to do is it allows us to scale out and grow very fast because all of our services are virtualized. So as we're adding new services and new cells, we stamp them out. It also means that we're kind of dogfooding our own stuff because the cloud has to work for us in order to make the cloud work for our customers. And we've actually learned some really interesting things over the last 18 months about what it takes to run a production scale operation in the cloud, which I think makes our cloud better for people that have to use it. The other thing that we've done is focused on a continuous delivery model. So this is developed in the open. There are literally hundreds of people contributing code into the project every day. And one of the things that there's different ways that you can deal with this, but the way we've decided to deal with it is every hour we pull down the latest code from the community, we merge in the latest code from Rackspace, and we run that on a test environment. We merge them, we run the dev test, we make sure that the dev test run, that takes us about 15 minutes. We then deploy that to our QA system. So we do a full packaging run, we wipe our entire QA environment, we deploy that whole thing, and we run another set of tests against it. That takes us about 17 minutes. 17 minutes to deploy it, 15 minutes to run the full functional test, at which point then we can publish to our staging environment, which is the last place we take a look at it before it goes to production. And all this is actually run by an automated Jenkins server. So we can, in theory, deploy an entirely new version of the cloud about 45 minutes after a new code change goes into it, which is one of the reasons. Now, that's an idealistic model. When it works, it goes this fast. I will tell you that right now we deploy about once a week. But for an operation of this scale, being able to deploy once or twice a week was actually a pretty big improvement for us, and probably an even bigger cultural shift for a company that likes to deploy things on a quarterly basis. So, so anyway, kind of wanted to touch on several of those things. I don't know how I did on time. I may have rushed through a little bit, but
4:55.
there you go. So just to summarize again, we really focus, so everything's open source. We focus very much on this idea of using our own stuff and using the cloud in a real world example. And then finally on making sure this continuous delivery automated pipeline is there so that we're constantly flowing changes through. And you know, Vid can tell us about a problem we have with our system, and within a week, hopefully we have that fixed and out in the new version of the product. So that's my 5-minute pitch. Love to take questions on any of this stuff that you want to know more about, or something related to that. Yes?
How do you solve any security concerns for private data or government data, anything like that?
So the question is, how do we solve security concerns for private data or government data? There's a number. That's a long question to answer. I'll tell you a few things that we've done. I mean, first of all, since we're running in a fully sort of virtualized environment, we have the normal protection of the hypervisors and the things that go on there. One of the technologies that's behind this that I haven't talked a lot about, that maybe I'll be able to talk about more in the future, is we're using software-defined networking to implement the network behind this piece, which is going to enable in a couple of months something called private networks in the cloud. So that I can actually build cloud servers that have a truly isolated private network that exists between them.